Row 1.text, Notepad window, text editor, editing, blank. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes eye and listen. Based on G scheme for Electronics Engineering Group. Subject, Digital Communication, 17,535. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Digital Communication Chapter 4. 1. B. Draw the block diagram of QPSK transmitter and receiver. Explain its working principle. Draw its constellation diagram. ANS, QPSK transmitter and receiver diagram, 2 marks each. Working principle, 2 marks. Constellation diagram, 2 marks. QPSK transmitter. QPSK receiver. Working principle QPSK is an expanded version from binary PSK, wherein a symbol consists of 2 bits, and 2 orthonormal basis functions are used. A group of 2 bits is often called a dibit. So, 4 dibits are possible. Each symbol carries same energy. The number of phase shifts in phase shift keying is not limited to only 2 states. The transmitted carrier can undergo any number of phase changes and, by multiplying the received signal by a sine wave of equal frequency, will demodulate the phase shifts into frequency-independent voltage levels, which is nothing but the demodulated output. This is indeed the case in Quadrature Phase Shift Keying, QPSK. With QPSK, the carrier undergoes 4 changes in phase, for symbols, and can thus represent 2 binary bits of data per symbol. Although this may seem insignificant initially, a modulation scheme has now been supposed that enables a carrier to transmit 2 bits. Digital Communication Chapter 4. 2. Of information instead of 1, thus effectively doubling the bandwidth of the carrier. D. Draw the DPSK transmitter and outline its working principle. ANS. Explanation 2M, Diagram 2M. Principle: it combines differential encoding and phase shift keying. In BPSK receiver, the carrier recovery is done by squaring the received signal. Hence, when the received signal is generated by negative data bit, it is squared, and thus we cannot determine if the received bit is BT or BT. Hence DPSK is used to eliminate the ambiguity of the received bit. Operation 1 DT represents the data stream, which is to be transmitted. It is to one input of an EXOR logic gate 2. The EX or gate output BT is delayed by 1 bit period the applied to the other input of EXOR gate 3. The delayed represented by BTTB. Depending on the values of DT and BTTB, the EXOR produces the output sequence BT. The waveform for the generator. The waveform drawn by arbitrarily assuming that in the first interval B, 0 equals 0,4, output of EXOR gate, is the applied to a bipolar NRZ level which converts BT to a bipolar level BT as. Digital Communication Chapter 4. 3. E. Write the bandwidth requirement for BASK, BFSK, BPSK, QPSK. ANS, 1 marks each for proper answer. Bandwidth requirement for BASK, 2 FB, BFSK, 4 FB, BPSK, 2 FB, QPSK, FB, where FB is bit frequency. B. With the help of block diagram, explain the working principle of QAM system. ANS, block diagram, TX, 2 marks. Explanation, 2 marks. Figure shows transmitter for 4-bit QAM system. The input bit stream is applied to a serial to parallel converter. For successive bits are applied to the digital to analog converter. These bits are applied after every TS second. TS is the symbol period and TS equals 4 TB dot bits BK, and BK plus 1 are applied to upper digital to analog converter. And BK plus 2, BK plus 3 are applied to lower D to a converter. Depending upon the two input bits, the output of D to a converter takes 4 output levels. Thus AET and AOT takes 4 levels depending upon the combination of two input bits. AET modulates the carrier square root PS cos 2 pi f0t, and AOT modulates square root PS sin 2 pi f0t. The adder combines two signals to give QAM signal. It is given as ST equals AET square root PS cos 2 pi f0t plus AOT square root PS sin 2 pi f0t. Digital Communication Chapter 4. 4. Block diagram, Rx, 2 marks. Explanation, 2 marks. The quadrature carriers are recovered from the received QAM signal. The input QPSK signal is first raised to the 4th power, and then by using a BPF, with a center frequency 4 Fc, along with a frequency divider, divided by 4, the required quadrature carriers are recovered. Then, two balanced modulators are used together with two integrators to recover the signal AET and AOT. Both the integrators integrate over one symbol interval say 4 TB. The symbol time synchronizer is used along with each integrator. Integrator output is AOT square root 22 TB and AET square root 22 TB. Finally, the original bits are obtained from AET and AOT by using 2A/D converters. The outputs of the 2A/D converters are then applied to the serial to parallel converter to obtain the sequence BT. C. Describe M-ary encoding. State any two advantages and one disadvantages of it. ANS, explanation 1 mark, 2 advantages -2 mark, 1 disadvantages 1 mark. M-ary modulation is a technique of modulation in which n bits are combined together to form M symbols, 2n equals M, and a signal is transmitted corresponding to each symbol for a duration of NTB equals Ts. The signal is generated by changing the amplitude, phase or frequency of a sinusoidal carrier in discrete steps. Thus M-ary modulation/signaling schemes can be categorized into the following types. 1. M-ary ASK. 2. M-ary PSK. 3. M-ary FSK. Advantages of M-ary scheme over the binary scheme are as follows. 1. Conservation of channel bandwidth. 2. Utilization of the additional bandwidth to provide increased noise immunity. Digital Communication Chapter 4. 5. 3. Increase in system performance. Disadvantages of the M-ary scheme are as follows. 1. Increase in the transmitted power. 2. Increase in error probability. Compare QAM and QPSK, any 4 points. ANS, 4 points 1 mark each. 2. List different digital modulation techniques and explain amplitude shift keying modulation in detail. ANS, list of modulation, 3 marks, ask block diagram, 2 marks, explanation, 2 marks, waveform, 1 mark. Amplitude shift keying, ASK, is the digital modulation technique in which the amplitude of the sinusoidal carrier will take one of the two predetermined values in response to 0 or 1 value of the digital input modulating message signal. Digital Communication Chapter 4. 6. Explanation. Amplitude shift keying is the simplest form of digital modulation. Here the carrier is a sine wave of frequency. The carrier signal can be mathematically expressed as equals sin 2 pi t the digital signal from the information source is a unipolar NRZ signal which acts as the modulating signal. The ASK modulator is nothing but a multiplier followed by a band-pass filter as shown in above figure. Due to multiplication, the ASK output will be present only when a binary 1 is to be transmitted, and when the digital input is 0 then we get 0 output as shown in the waveform above. From the waveform analysis we can conclude that when a binary 1 is to be sent the carrier is transmitted, and when binary 0 is to be sent then the carrier is not transmitted. Mathematically ASK signal can be expressed as 3. Compare ASK with FSK modulation. ANS, any 4 relevant correct points 4 marks. 4. List different advantages of PSK modulation. ANS, any 4 advantages, 4 marks. Advantages of PSK. BPSK has a bandwidth which is lower than that of a BFSK signal. 2. BPSK has the best performance of all the systems in presence of noise. 3. It gives the minimum possibility of error. 4. BPSK has very good noise immunity. It gives less error of probability. 6. Used for high bit rate than 1800 bits/section. Digital Communication Chapter 4. 7. C. Compare between BPSK and QPSK. Are to variable characteristics of the carrier, type of modulation, bit rate/baud rate, and application. ANS. D. Draw and explain PSK transmitter block diagram. For MANS, 1. The simplest digital modulation technique is shift keying, PSK. 2. It is a digital modulation technique, in which the phase of the analog carrier is changed with respect to the binary input information keeping its frequency and amplitude constant. 3. If binary input is logic 1, phase of analog carrier is shifted by 0, 0. 4. If binary input is logic 0, phase of analog carrier is shifted by 180, 0. Block diagram of PSK transmitter. Working of PSK transmitter. Digital signal acts as modulating, or information signal, which is fed to first level converter to change voltage levels from +V to 0 to +V to V. The level shifted signal and analog carrier SIN, CT, is given as I/P to balance product modulator. When the binary input is positive we get the carrier signal as it is, and when binary input is negative we get the carrier signal phase shifted by 180 degree. Output of balance modulator is fed to BPF to allow only wanted frequency to pass through it. Digital Communication Chapter 4. 8. C. Compare QPSK and QASK, any 4 points, for MANS. C. Draw and explain the block diagram of FSK with suitable waveform. For MANS, block diagram of FSK. Explanation, 0 to M. In FSK, the frequency of the carrier is changed with respect to the input bits 1 and 0. In case of binary data, 2 carrier frequencies are used. The carrier frequency corresponding to logic 0 or binary 0 is called as space frequency, and the carrier frequency corresponding to binary 1 is called as mark frequency. As shown in figure, the input binary data is given directly to the multiplier and is inverted and given to second multiplier. Digital Communication Chapter 4. 9. 2 different carriers have different frequency generated by the 2 oscillators and applied to the multipliers. The output of both the multipliers is an ASK signal, which is added by the summer. Thus, the output of the adder is the BFSK wave. Waveforms.